Hydraulic systems come in many configurations and can be simple or complex. To understand how the hydraulic system works, let's take a look at a typical hydraulic system. The primary components of a hydraulic system are a power source, a pump, the actuator, the directional control valves, the reservoir, the hydraulic filters, and the hydraulic fluid. Hydraulic systems do not generate power, they transfer energy. Every hydraulic circuit requires a power source, such as an engine or electric motor. In hydraulic terminology, this source is known as a prime mover. Power from the prime mover is introduced into the circuit by the input component, usually a pump. There are three basic types of pumps used on hydraulic equipment: gear or rotary pumps, piston pumps, and vane pumps. Actuators are output components which do the work in the form of linear power, a cylinder, or rotary power, a motor. The directional control valves are flow control valves which regulate the direction of flow and pressure in the hydraulic circuit. The reservoir is a holding tank which functions to store fluid, cool fluid, provide air separation, and provide for easy fluid maintenance. The hydraulic filter's primary function is to clean the hydraulic fluid by removing damaging contaminants. Hydraulic fluids perform four primary functions: transmit power, lubricate moving parts, such as pumps, valves, and seals, seal internal components, and cool or dissipate heat. When selecting a hydraulic fluid, follow the manufacturer's recommendations. While hydraulic fluids play a vital role in keeping a hydraulic system operating properly, over 75% of all system failures are a direct result of contamination. Contaminants in hydraulic fluid include particulates, such as dust, dirt, sand, rust, fibers, elastomers, and paint chips, wear metals, water, sealant, such as Teflon tape and paste from repairs, sludge, oxidation, and other corrosion products, acids and other chemicals, and microorganisms in high water-based fluids. Contaminants can enter a hydraulic system in several ways: built in during the manufacturing and assembly process, internally generated during normal operation, and ingested from outside the system during normal operation. Built-in contaminants include dust, welding slag, rubber particles from hoses and seals, sand from castings, and metal debris from machined components. If the hydraulic system is not properly flushed, these contaminants will be left in the system. Also new, unfiltered hydraulic fluid initially added to the system can be a source of contamination due to cross-contamination and also to the complexity of new additives in the fluids. Pre-filtering of new hydraulic fluid is important to prevent this form of contamination. Internally generated contaminants occur during normal operation as component wear debris and chemical byproducts react with component surfaces to generate more contamination. Hydraulic systems wear in many different ways. Adhesive wear results when moving parts tend to stick together. Abrasive wear is caused when hard particles wear on adjacent surfaces. Fatigue wear is surface failure that results from the reversing of loads. Corrosive wear is the loss of material over a large area, typically caused by water or chemical contamination in the fluid. Cavitation wear, or the formation of partial vacuums within the fluid, is caused by drastic pressure changes. These pressure changes, while microscopic, can cause severe damage to the metal in contact. Erosive wear occurs when fine particles in a high-speed stream of fluid eat away a metering edge or critical surface. Ingested contaminants come from the surrounding environment. Most dirt particulates enter the hydraulic system through vents, breather caps, worn seals, and cylinder rods, and other system openings. Particulates in the 1 to 20 micron range are typically the most damaging to the hydraulic system. Water can also be ingested into your hydraulic system through condensation, seals, and vents. Water in hydraulic fluid can cause chemical corrosion. Water can break down fluid additives and chemistry, destroying the lubricating properties of the fluid. Elevated temperatures and high flow rate can lead to further breakdown of the fluids. Elevated temperatures can speed up the breakdown of the fluid, while the high flow rate can lead to electrostatic discharge, which also accelerates the breakdown of the fluid. Poor preventive maintenance practices are the leading causes of hydraulic system and component failures. Following proper maintenance practices can eliminate most system failures. Along with good maintenance practices, proper filtration is the most effective method for controlling contaminants in your hydraulic system. Baldwin manufactures a wide range of hydraulic filter products to help keep your equipment running efficiently. You will learn more about how to choose the right filter for your application in the Filter Types section.